Voyager 1, NASA's most distant spacecraft, dares to venture into the dark, unexplored regions of the cosmos. Almost 50 years after launch, this iconic space probe continues its mission. But the information it sends back to Earth is not only confusing, but deeply disturbing. The signals are strange, almost scary, and point to something that may be beyond our current understanding. What could be the reason for these deviations? Is Voyager 1 encountering something we don't yet understand? Join us as we explore the strange and confusing signals that Voyager sends back during its interstellar journey. It all started decades ago with humanity's insatiable curiosity to understand our own dimensions. The launch of Voyager 1 and its twin, Voyager 2, was inspired by this very curiosity. Among other things, these spacecraft were designed to explore the unknown, sending back images and data that could help us piece together the mysteries of our solar system and beyond. Voyager 2 left NASA's Kennedy Space Center on August 21, 1977, followed by Voyager 1 on September 5 of the same year. Although these spacecraft were launched separately, they had to change places in space along the way. Voyager 1 quickly passed its twin in December of that year and began its Jovian imaging mission in 1978 at an astonishing 2,665 million kilometers from Earth. It sent back a wealth of photographs, including an astonishing 3,750 images of Jupiter's rotation taken over a 108-hour period in January 1979. These images, which were converted into slow motion, showed 10 revolutions of the planet and provided a visual picture. A celebration of gas giant dynamics. Passing through the Jovian lunar system in February 1979, Voyager 1 discovered a faint ring around Jupiter and two new moons, later called Thebes and Métis. Voyager 1's journey was far from over. It was carefully maneuvered to ensure a successful flyby of Saturn, avoiding possible collisions with its moons. In 1980, the spacecraft discovered 4 more Saturnian moons, Mimas, Enceladus, Tethys, and Dione. These discoveries marked important milestones in our understanding of exoplanets and their systems. After the Saturn encounter, scientists decided to end Voyager's planetary mission and instead send both spacecraft on a trajectory that would take them outside our solar system at a speed of 325 million miles per year. In January 1990, the Voyager interstellar mission officially began. Some of the most famous photos in history of the Sun and most of the planets were taken by Voyager 1 on February 14, 1990, 6 billion kilometers from the Sun. These images, often referred to as the Solar System Family Photo, were the last images taken by the spacecraft before its cameras were shut down to conserve energy and memory for the journey in interstellar space. Voyager 1 continued its solitary journey by passing Pioneer 10 on February 17, 1998, becoming the most distant man-made object in space. It traveled for another 14 years before reaching the interstellar medium on August 25, 2012, although NASA did not publicly announce the achievement until 2013. By November 2018, both Voyager spacecraft had left the solar system, and Voyager 2 had crossed the heliopause and entered interstellar space. Space middle today, Voyager 1 is about 14.5 billion miles, 23.5 billion kilometers, from Earth. It went into areas that other spacecraft have not, providing us with valuable information. However, its long journey was not without its challenges. Although it has spent most of its 45-year journey in good health, it has recently seen strange anomalies in its operations. Voyager 1 is currently sending mysterious signals back to Earth, giving the impression that it is unsure of its location coordinates. Strangely, despite these anomalies, no alarms were triggered and its antenna appears to be in good condition. These data are dubious and obscure researchers. The interstellar probe continues to operate regularly, taking instructions from Earth and carrying them out while collecting and transmitting scientific data. However, the articulation and steering system of the sensor does not accurately reflect what is happening on board. This difference has caused much speculation and concern in the scientific community. Could cosmic rays alter some of the spacecraft's sensitive electrical systems? These high-energy particles, originating from distant supernovae or other cosmic events, travel through space at nearly the speed of light. If they hit Voyager 1, they could penetrate its exterior and hit internal electronic components, causing random anomalies like those now observed. Engineers have long been aware of the potential dangers that cosmic rays can pose to spacecraft electronics and human passengers. Various strategies have been implemented to protect spacecraft from these high-energy particles, including shielding sensitive electronics, designing redundant systems, and using error correction codes in data transmission. Even with these precautions, cosmic rays are still a serious threat, especially for spacecraft like Voyager 1 that operate in deep space for long periods of time. Interacting with Voyager 1 presents its own major challenges. The spacecraft is currently about 14.5 billion miles from Earth, and messages sent at the speed of light take almost 21 hours. This significant delay makes real-time problem-solving nearly impossible, requiring careful planning and execution of each command. After Voyager 1 has processed the command, it takes another 21 hours to return the sent responses or data, meaning that two-way communication takes an average of 2 days. This delay is a major challenge for fixes or the iterative troubleshooting that is often required when solving complex technical problems. Each command must be carefully designed by engineering to solve known problems without causing additional problems because of how long the command takes to control the desired effect. Unlike missions closer to Earth, where engineers can quickly send and receive commands, the long communication delay requires a more strategic and patient approach. Each driver must be carefully tested and validated on Earth before being sent to Voyager 1. The spacecraft itself is also more than 4 decades old, having launched in 1977. The technology on board, although cutting-edge at the time, is considered ancient by today's standards. The engineering team must work with equipment and systems designed and built in the 1970s, which adds another layer of complexity to the problem-solving process. The harsh environment of the spacecraft also stresses the spacecraft systems. For more than 45 years, Voyager 1 has been exposed to cosmic rays, extreme temperatures, and micrometeoroids, which have contributed to the wear and tear of its parts. Despite these enormous challenges, the design team remains committed to solving the current problems. They explore different hypotheses about what could be causing the anomalies and test possible solutions using simulations on Earth. This careful and methodical approach takes into account the necessary contributions. Any wrong command can worsen the situation or cause a loss of communication with the spacecraft.
The crew will also benefit from the redundancy built into Voyager 1 systems. Like many space missions, Voyager 1 is designed with backups to increase its resilience against failure. The engineering team may be able to switch to these backup systems to restore normal operation if they detect a failure in a particular part. The recent anomalies in the Voyager 1 data are puzzling, but not entirely unexpected given the spacecraft's age and prolonged exposure to cosmic rays. Engineers and scientists continue to monitor the situation and analyze data from Voyager 1. They are working to determine the exact cause of the anomalies and develop strategies to mitigate their impact on spacecraft operations. Despite these challenges, Voyager 1 has far exceeded the expectations set for its original mission and continues to provide valuable information about our solar system and beyond. Its achievements are a testament to the ingenuity of its creators and the dedication of the team that has supported it for more than 4 decades. Voyager 1's journey is a reminder of humanity's continuing curiosity and determination to explore the unknown dimensions of space. Looking to the future, missions like Voyager 1 inspire and expand our understanding of space. Malfunctions can be caused by cosmic rays that alter the spacecraft's sensitive electrical systems. These high-energy particles, originating from distant supernovae or other cosmic events, travel through space at nearly the speed of light. If they hit Voyager, the particles could penetrate its magnetic field and hit internal electronic components. The longer a spacecraft remains in space, the greater the chance that cosmic rays will affect its systems over time. This phenomenon can cause random anomalies, such as those currently observed in Voyager 1 telemetry data. Engineers have long been aware of the potential dangers of cosmic rays to spacecraft electronics and human explorers, but the extent of their effects can be difficult to predict or mitigate. Despite these challenges, engineers have adopted various strategies to protect spacecraft from cosmic rays, including shielding sensitive electronics, designing redundant systems, and using error-correcting codes for data transmission. Even with these precautions, cosmic rays can still pose a threat, especially to spacecraft operating in deep space for long periods of time, such as Voyager 1. While the recent anomalies in the Voyager 1 data are puzzling, they are not entirely unexpected due to the age of the spacecraft and prolonged exposure to cosmic rays. Engineers and scientists continue to monitor the situation and analyze data from Voyager 1. They are working to determine the exact cause of the anomalies and develop strategies to mitigate their impact on spacecraft operations. Despite these challenges, Voyager 1 has exceeded its initial expectations and continues to provide valuable information about outer regions.